And here we go. Yesterday we sketched the parent function for cosecant. In order to get the graph of secant, what do you think I graphed first? Cosine, because cosine is the reciprocal. So as I graph cosine, I'm going to make a period of 2 pi, divide it in half to get pi, divide that in half to get pi over 2, and 3 pi over 2. Did you just say writing these in is getting annoying? That would be very normal if you're feeling that way. However, I will just state again that the number of times I've encountered an AP problem with my ability to write those out to save me time on a test, it's been significant, or even on the ACT. So repetition will hopefully help us. You are not very far away from leaving writing those out, and so it'll be a good time. All right, maximum 1, minimum -1. Where does it start? Middle, max, or min? I've heard middle. I've heard top. Anybody for bottom? Why is it top? Cosine starts at the max or min. Sine starts in the middle. So cosine starts at the max or min because of positive we start at the max. I had frozen pizza last night. I did lots of matzah last night because it was $5.99. So. Yep. No, Gavin. Now, if you remember from yesterday, the relationship between secant and cosine is that they are reciprocals, right? What's the reciprocal of 0? Undefined. So if it's undefined, what do I draw? A vertical asymptote. Right now, our good friend Olivia, she was not here yesterday, and she's sitting there just a little confused. Right, Olivia? But here's all Olivia needs to really know for today, as well as you guys. First of all, do you understand why we sketch cosine? So the cosine graph, no big deal. Second thing, just put vertical asymptotes wherever it crosses over the x-axis there. Then finally, the actual graph, because none of this is the actual graph yet, is it? The actual graph, I just simply plot at the maximum and draw a U-shape. Minimum, draw a U-shape. Maximum, draw a U-shape. Minimum, draw a U-shape. Maximum, draw a U-shape. And that's the parent function for secant. How's that? Yes.
Like a graph like the whole dot thing, it just doesn't work well in my brain. But so like if I graph it like that and I have these, is that gonna be wrong?
So right now I would take So right now I would maybe take a half a point off on your graph because I don't know what your vertical tick marks are. Is that 1? Is it 2? Is it 4? She's good. Hannah, what should we do? She just said delete. She's just going to delete what she wrote. We can't. That's impossible. Okay. Let's see what you can do. We're going to do these 3. Flip it over. We're going to skip the top. We're going to go straight in the graph. What do I start by graphing? Sine. Just to make my point as people are thinking about that. So these are kind of the original trig functions, these 3. And so these are the complements. So sine has a complement. Secant has a complement. And tangent has a complement. They all have a complement. That's why you have the co. See what I'm saying? That's why it is what it is. I know you kind of want to see all the co's go together, right? It's not that way, and this is why. It's they have a complement to each other. That's kind of how it works. So anyway. You raised a really good point, and I did start this class by telling you that this actually means your nasal passage, right? Yeah, so they messed up in translation. So started as Greek, went to Arabic, came back as Latin, and now in English, and it's all messed up. So let's start our own math. All right. True that. Y is equal to 2 sine of x. So what's the period? 2 pi? Do the dreaded markings. What is the amplitude? Dos, which is Spanish for 2. Notice how I'm not going to put 2 all the way up at the top because I need space at the top. I'm going to give good marking so that the person grading my work can be confident that I know what I'm doing. Where does this graph start? Up. Does it go up or down? It goes up and down, down and back up. What's my next step? The asymptotes. Good. Wherever it crosses the x-axis. What's the last thing I do? Look at your maximums and minimums and draw those U-shapes. Yeah, nothing that I've drawn up to this point is actually the graph. Now, Ella said that she doesn't really like to draw the first dotted part. That kind of confuses her. I can live with that, but what I can't live with is people don't draw the asymptotes sometime on the test. I need to at the very least see the asymptotes. The asymptote is an important part. Okay? And then make sure that there's enough evidence on your graph so that I can see what the heck you're doing. All right, this one, instead of graphing secant, I start by graphing what? Yep, -3 cosine of 2x. What's the period? Period's pi. What do you do, Laura? All right. My maximums and minimums are going to be what? -3 and +3, as there's an amplitude of 3. Notice how I give myself space at the top and the bottom for this graph. Where do I start? Start at the bottom. How come?
Negative cosine.
Good. Cosine starts at max and min, and because it's negative, starts at the bottom. Again, I can see ahead to the classes you're taking. I can see the rest of trigonometry. I can see calculus. I can see how much it's going to benefit you that you know some of these things. It's definitely sinking in for you. This is good. Okay. Next step. Asymptotes. And now my U-shapes at the max and min. I can't resist. I just think it's fun. So sorry, you have to bear with me on this. -3 divided by cosine of 2x. And then we're going to go -3 cosine of 2x. I'm going to put that one as a dashed line. So that's bold, shade up, shade down. And there I have a dashed line. I'll go into my window, x min. We're going to go -pi. Max, we're going to go positive pi. Every tick mark is pi over 4. And my y minimum, we're going to go -7 on that and positive 7. And I'm going to graph it. Like, a lot of times people just think we're just sketching random things. I mean, it's perfect, isn't it? All I did is instead of doing secant, I did -3 divided by cosine because it's reciprocal. But I mean, I don't think we're just making like rough sketches. I think we're pretty much exact. So you gotta just divide. Yeah. No, I just press divided by it. It's not much more. So, okay, here we go. Last one. We're not going to use all this space. We're going to put everything together. So we have a horizontal shift. We have a vertical shift. We have amplitude and period. Instead of sine or cosine, we have secant. And so this is kind of the pinnacle of all the problems we've done. We end with this. You'll have the rest of the time to work. I start by graphing y equals -4 cosine of 2x plus pi over 2 plus 2. My teacher told me that when I graph that, what part of the graph do I start with? Which transformation? Start with the vertical shift, which is 2. And then the amplitude, which is 4. So if the vertical shift is 2 and the amplitude is 4, what's the highest point of the graph? So I'm going to go 2, 4, and 6. So I'm going to make tick marks like that. I'm not going to use this whole space. What's the minimum value of the graph? -2. So from the center of 2, I go 4 up and 4 down. Great, I got those two pieces taken care of. I now move on to the, let's see, the period. What's the period going to be? Pi. Mark that out. Again, I'm not going to use the whole space. I don't need all of it. Got pi over 2, pi over 4, 3 pi over 4. -pi, -pi over 2, -pi over 4, -3 pi over 4. And I'm now going to show you a trick. Normally at this time we make a ghost graph, don't we? Wouldn't it be challenging if we made a ghost graph on top of a ghost graph? Everybody agree that that's not the best practice, is it? So let's determine the horizontal shift, and I'll again talk about the trick that we did yesterday. Horizontal shift, I'm going to take 2x plus pi over 2 and set it equal to 0. If I subtract the pi over 2, I get 2x is equal to -pi over 2. So therefore, what is x? X is -pi over 4. Since it's negative, I shift it to the left. Nope, I'm going to shift it to the left, and I'm going to shift it to the left 1 tick mark. So watch how I avoid making another ghost graph. Here's what I'm going to do. Where does the cosine graph start? Starts right here, right? So you could go ahead and make a ghost graph and then shift everything, or you could do this. I start at the bottom, right? And from there I would head up, agreed? So what I'm going to do is, instead of starting here, I'm just going to back up one. And then from there, I will go up and up. And that way I don't have to make a second ghost graph. What was the question? Now, we don't draw the vertical asymptotes where they cross the x-axis. We draw it where it crosses its axis of rotation. So I draw it there, here, 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 here. Where it crosses the vertical shift, the axis of rotation right there. You are correct, it is a horizontal line. Thank you. If I could just have your attention for one more second, if people could look at this, please. Y is equal to x squared. When you guys had Miss Kruger for a while, you learned how to graph those, didn't you? And then you decide to do this thing where you like flip them upside down, or you even flip them upside down and shifted it up 1 unit. And then you had, say, Miss Hanson, and she said, well, we're going to have you actually do this. We're going to flip it upside down, and we're going to shift it to the right 3 units and add 1 to it. And then she even said, we're going to create like a compression or a stretch, right? And then he came to my class. We said, forget about that. You're going to do square roots as well. You're going to do 1 over. You're going to do logarithms, all those things, right? Look at where it's brought you. We are still doing transformations. The difference is this transformation sits inside of a secant function. And so you are getting a review of that piece, which for those of you who will be taking the ACT, which is most of you, that's a good thing that we're continuing to see that, because that'll get you a couple points on tests. ACT is on April 5th. Yes, sir.
Speaking of the